All right, 2.3, solving linear equations. I really feel like 2.3 is really just an extension of the types of problems that we did in 2.2, maybe a little more complex, but a lot of it's the same. There's really two new things that we'll have to look at, and that's some of these that have all reals or no solutions, and we'll do some examples of those problems. All right, so first example, negative 4y plus 8 equals negative 2, 3y plus 4. And actually, before we get too into that, I do want to show you a slide from the PowerPoint that I think is very important. And it's this one right here. I actually stole it from one of the classes I go into at Vanguard. One of the teachers had it up on the wall, and I really like it because if you just kind of follow these steps, it really helps you as far as solving these equations. So for the most part, anytime you have to distribute, that's going to usually be the first thing you're going to do. Okay. And then if they have any fractions, and we're going to talk about what you do with the fractions, but you'd want to eliminate the fractions. And it talks about combining the like terms. So remember, on each side, before we start moving constants and variables around or canceling out constants and variables, we want to make sure we've combined all like terms on each side. Now, the only thing I do a little bit different is you normally see me deal with the variables first. So usually I would switch these two because I'm going to move all the variables on one side and then I move all the constants. But it doesn't matter really what you do. If you want to move your constants first, then move your variables. But once you do that, you're going to combine. You probably won't have to do that, but you're really just simplifying. If you had constants already on one side, you're just kind of cleaning that up. And then your last step, obviously, is solve. So usually once you move everything over, by that point, by most, there'll be a two-step algebra equation. But just depending where it's at. But I really do like this. I kind of took a picture of it and I threw it into my PowerPoints. Because if you kind of ask yourself these steps as you're going through the process, it kind of makes it a little bit easier. All right, so going back to this example, you do notice here we're distributing. Okay, so we're doing negative 2 times 3y, which gives us the negative 6y. Negative 2 times 4 would give us the negative 8. So at this point, you'd ask yourself, do I have to simplify either of these two sides? No, they're already simplified. We have a constant and a variable, constant and a variable. So now we're on to that step where we have to move all the constants on one side, all the variables on the other. Okay, and like I said, I normally will do my variables first. I like to get all my variables on one side. And you could either add 4y to both sides or add 6y to both sides. So in other words, I want to either eliminate this variable here or eliminate this variable here. Just in this, normally I want to try to keep a positive variable. Okay, so if I add 4y, this is going to leave me with a negative 2y. So that is why I'm going to add the 6y to cancel out this variable. And that's going to leave me with a positive 2y here plus 8 equals negative. And again, you notice I'm just moving down the plus 8, moving down the negative 8. So hopefully at this point you see this is what I call a two-step algebra equation. I have two steps to do in order to get my y by itself. Right? And remember, what's happening here, this is 2 times y, and then this is a plus 8. So remember, we always want to add or subtract first, because to get rid of this 2, I have to divide. I don't want to divide everything by 2. I just want to divide one number here and one number on this side. So we're going to subtract that 8. to get rid of this because I'm trying to isolate this variable. I'm trying to get this y value by itself. Okay, -8 minus 8 gives me -16. So that was my first step. And now my last step is to get rid of the 2. And since, again, it's multiplying, the inverse operation would be division. So my answer is just going to be y equals -8. Negative divided by a positive gives me a negative. Anytime I'm dividing or multiplying by a positive and a negative, my answer is a negative. All right. So, and again, this is really like I said, a review of 2.2. This is what we were doing a lot of in 2.2. Let's look at what do we do when we have fractions. And the fractions they give you in 2.3 are a little easier than the fractions we're probably going to see a little as we get a little further into this. So fractions and fractions in general would probably frown upon. Fractions and equations would probably really make you frown. But I really kind of teach a really easy way to kind of eliminate these fractions and make the equation look a lot easier. All right, so what you're going to do is when you look at these denominators, in this case, it's pretty easy because they're all 7. Okay, but if your denominators were different values, you would want to come up with your LCD. Okay, but let's just talk about this one since they're all 7s. I can do something to eliminate all those fractions. Okay, and that's really our second step. Remember, we're distributing would be the first thing, and then eliminating fractions, if you remember back to that slide, was the second thing. So I don't have to distribute here. So I can eliminate these fractions. The way you eliminate these fractions is by, again, in this case, it's just all 7s. But what I can do is I can just multiply everything in this equation by 7. All right, and again, everything. So if there was another variable or something out here, I'd have to multiply that by 7 as well. But when I multiply everything by 7, what does it do? It cancels out. It eliminates all those 7s in the denominators. So now the equation just looks like this. All right, it just basically leaves us with our numbers that were in our numerators. 2x plus 1 equals -3. So again, comes back to kind of where we were right here. It's a 2-step algebra equation. We want to eliminate the +1 first because my goal is to get this x by itself. So I'm going to subtract 1, breaking down the 2x. So I have 2x equals -4, and then I'm dividing each side by 2, and I'm going to get x equals -2. All right, so I'm eliminating the fractions and then solving the algebra equation, 2-step algebra equation once I get to that step. Let's do another example with fractions. All right, similar problem, but we don't have a fraction everywhere. So when we're looking for if we have to distribute, in this case we don't. So we're looking at these fractions, okay? And these that don't have fractions, I don't really care about. I only care about the 2 where I see these fractions. And how do I get rid of these numbers that are being divided by 8? I would just multiply by 8, right? So if I was able to multiply this by 8, it would cancel out those 8s. Same thing here. But don't forget, I have to do it everywhere. So that 3x also has to be multiplied by 8, and this 4x must be multiplied by 8. So everywhere I have to multiply by 8. Not a big deal. 8 times 3x gives me 24x. On this one, those 8's cancel, so I'm just left with the value in the numerator, which is 5. 8 times 4x would give me a 32x. And again, the 8's cancel here, so I'm just left with the minus 5. All right. So our next step is what we notice is we have variables on both sides. So I got to eliminate one of them. If I move the 32 over here, that's going to leave me a negative value. So I'm probably going to eliminate the 24, okay? So I'm going to subtract 24x. Again, if it has a variable, you got to include the variable. So that'll cancel that out. I'm going to move the plus 5 down. That minus 24 is going to go under my 32x because it's my like term. And then I'm going to move this negative 5 down. Let's see what we have. We have 5 on this side because the 24x is canceled out. 32 take away 24x leaves me 8x. And then I move down to negative 5. And one of the things I wanted to stress too, even though our first two examples came out to really pretty numbers, what you're going to notice a lot with 2.3 is we're not going to have a whole lot of, don't be surprised if you don't have pretty numbers in your answers, if you have fractions in your answers, okay? Doesn't necessarily mean you did something wrong, but just be prepared for that, because even when I get those fractions in my answers, I think maybe I did something wrong. So I check it and then I find out I didn't, but just be prepared. You may have some fractions in your answers. All right, so once we get to this point, it's a two-step algebra equation. I'm trying to get this x value by itself. I'm going to eliminate the minus 5 first by adding 5 to both sides. Bring down the 8x. 5 plus 5 over here will give me 10. And now I'm going to deal with the 8 by dividing 8 to both sides. So what I get is x equals 10 over 8. Hopefully, if you haven't heard it before, you're going to remember that I cannot leave this as my answer because it is not simplified. And the number one indicator you know it's not simplified is because you have two even numbers. Never enter a fraction with two even numbers on it, okay? Because that tells me you, at the very least, I should have divided each of those by 2 until I didn't get even numbers, all right? So if you divided it by 2 and then you still had 2 even numbers, keep dividing it by 2 so you don't, okay? And usually you're going to have it simplified. So when I divide both the numerator and denominator by 2, I'm left with 5 over 4. And that is my simplified answer there. All right, so let's do some examples of when you're going to have an answer of all real numbers or an answer of no solution. Because that's really the new stuff that you'll see on 2.3. Because you're going to be able to enter a value, or you're going to have to say it's either all reals or no solution. We'll talk about when you have all reals and when you have no solution. So we notice here we have a distribute that we have to do first. When I do that, I'm going to get a 20x plus 4 equals 20x plus 4. So at this point, I know something weird's going on, okay, because I have the same value here as I do here. But even if you didn't necessarily notice that, you'd have to maybe subtract 20x to both sides. And what happens is both those 20x's would cancel each other out, and you're going to have 4 equals 4. Well, what we know is 4 does equal 4, right? So that is a true statement. So that means our answer is all real numbers. And what that really tells us is no matter what value I put for x, this would be a true statement, okay? Because really these two sides are equal, all right? So all real numbers. If you really could have known you had all reals once you got this. Once I had the same thing on both sides, I know my answer is all real numbers. So let's look at the other special circumstance. Example 5. I have 6x minus 4 here. I have to distribute this side. That's going to leave me 6x plus 36. So what you notice, I have 6x minus 4 on this side and 6x plus 36 on this side. All right, so the next step is to eliminate. I like to move all my variables to the same side. Well, I have the same variables. When you know you have the same thing on both sides, what's going to happen is they're going to cancel each other out. When I subtract 6x to try to eliminate them, that one's gone and that one's gone as well. So what I end up having is negative 4 equals 36. So you ask yourself, does negative 4 is equal 36? Is negative 4 and 36 the same? The answer is no, it's not. Okay, and that is the situation where your answer would be no solution. That means there is not a number that I can put in here for x that would make these two sides equal. Okay, so again, see the difference when I get 4 equals 4? That means any number I put in would make this a true statement. This one, no number. There is no solution. See, all these other ones, we can't come up with an answer, whether it's a fraction, whether it's a value. Okay, but sometimes it'll be all reals, and sometimes it'll be no solution. But don't fall in love with this as an answer. Because sometimes people try to solve it and they think, well, just because I can't solve it, it must be no solution. Okay, so remember, you want to kind of work these a little bit first and see if we could come up with a solution. All right, so let's look at more examples. I want to look at this one. Number 6. And these are z values. You have a negative z here, and 9 minus z here, and a 2. So if you think back to, again, that slide, that first slide I showed you from the PowerPoint, what it talks about is always distributing first. And one thing I want you to keep in mind is this whole 3 times 9 minus z is my numerator. That whole thing is being divided by 2. All right? So just kind of keep that in mind. So I'm going to have 27 minus 3z. Once I distribute that 3 into that, and then that whole thing is being divided by 2, and then it equals negative z. So distribute, first step, and then we talk about eliminating fractions. And so we do kind of have a fraction here. And the way I eliminate it is just multiply that value to both sides. Or everything. And again, the reason why I'm not multiplying it here and here is this really is, since it's in that numerator, you think of it as one term. Okay? So yeah, technically I would multiply 2 into both things, but in one sense, what's going to happen, it's going to just cancel out anyways. All right. So these 2's would cancel out, and I'm left with 27 minus 3z. And then here, 2 times z gives me a negative 2z. All right. Let's kind of go through that one more time, because that's a little bit different now. Okay, so you're going to distribute first. I get 27 minus 3z, but again, this whole thing is in my numerator, and it's being divided by 2. So I really can't work within here until I get rid of this 2. So what I do is I multiply the 2 to both sides. It'll cancel out here, and then here it multiplies to that z. And I just move, because since this 2 canceled out, I could just move what's in these parentheses down. All right, so now I'm solving this. I got variables on both sides, so I got to move one of the variables over. So this is something I would never do, okay? I would never get rid of this by adding 2z to both sides, because it would end up putting a 0 here. And I don't really like to do that, because then I'd have to move the 27 over, just be a little more work. So I'm going to move this negative 3z. But if you did do that, you could do it as long as you followed your algebra rules. You should be able to get it right. I'm always looking for things that are going to make my life a little bit easier. Okay, so I'm up minus 3z. The opposite is plus 3z. Cancels these out. Minus 2 plus 3 would actually give me a 1z, positive 1z, or just z. So I'm done. That was a lot easier than if I move this over, had a 0 here, then I'd have to move 27 over, divide by negative 1. So I'm done once I get to this point. They don't spend a whole lot, you don't have a whole lot of examples with decimals. But they do want you to solve these that do feature decimals. And all I would tell you guys is you're going to kind of solve it the same way. We're trying to get the x by itself. So you do the inverse operation. I'm not doing anything with the 0.8. I'm dealing with that 0.8 last. All right, and this is where I go to my calculator. 0.2 plus 2.2. So I'm going to have 0.8x equals 2.2. I'm going to divide 0.8 to both sides. 2.4 divided by 0.8. And you would get x equals 3. Now these other examples are just a little more in-depth types of problems. I have 4 of these where I'll kind of work through them with you a little bit. So we have 4, 2n plus 2 equals 6, 5n plus 8 plus 8. So this is our next example. We have to distribute here, and I have to distribute here as well. And I'll just move down that plus 8 once I do that. So 4 times 2n will give me an 8n. 4 times plus 2 gives me a plus 8 equals 6 times 5n gives me 30n. 6 times 8 gives me 48. And then again, I'm just moving down the plus 8. All right, so before I start solving anything else, I do have to combine some like terms. And I have some constants right here. I got to simplify them again before I start moving things from one side to another or eliminating things. I want to make sure they're simplified. So I go 48 plus 8 gives me 56. So again, now is when I want to either subtract the 8n from both sides or subtract 30n from both sides. I got to get rid of one of those variables. I prefer not to have a negative as my variable. So I'm going to get rid of the 8n. By subtracting 8n, I'm doing that'll eliminate that 8 there. Move these other values down. So 30 take away 8 would give me a 22n. And move the plus 56 down. All right, so we have a 2-step algebra equation. At this point, you got to, before I deal with the 22, I'm going to get rid of the plus 56 by subtracting 56 to both sides. Moving down the 22n. 56 is now canceled each other out. 8 take away 56 would leave me with a negative 48. Now I'm going to eliminate that 22. It's being multiplied by the n. I'm going to divide 22 to the n. And again, why would I not leave negative 48 over 22 as my answer? hopefully you all say, because we don't leave even over an even. These are both even values. So again, you know, at the very least, I can divide 2 into both of those. And that would give me 24, negative 24, and then 22 divided by 2 gives me 11. Okay, and at that point, it can't be simplified anymore. So remember, we talked about we were going to get some not so pretty values in 2.3, and we're not going to freak out. But again, it's a little in-depth type of problem. This is pretty much the most work that you'll have to do. And again, I kind of just do it step by step. Just remember, if you enter that and you get it wrong, you're going to freak out. But the reason why it's wrong at this point is you did not simplify that fraction. Well, a few more. Actually, let's do 2 more examples. All right. Okay. First step, distribute. Always. If you have something that has to be distributed, we are going to distribute first. 7 times 7x gives me 49x. 7 times negative 8 gives me a negative 56. And then I have a plus 7x and a plus 2. I do like this example because after we distribute, we are supposed to eliminate fractions. We don't have any fractions, but we do have to clean this up a little bit. This side is already simplified, but if you look over here, we have like terms, right? We have 49x and 7x that can be added together. And then we have these constants, negative 56 and a plus 2 that can be added together. All right, so 49x plus 7 will actually give me a 56x. Move our other stuff. We haven't done anything on this other side. And then a negative 56 plus 2 would give me a negative 54. So if I simplify this side correctly, what do you notice at this point? Both sides are exactly the same. When you get both sides that are exactly the same, you know your answer is all real numbers. They're all reals. Okay, so it doesn't matter what value you put in for x, it'll make it a true statement. But you can't just say x equals 5, I mean, because it equals every number. All are real numbers. So we just kind of get to this point. Once you see these two sides are the same, you're good. You can stop and just say it's all reals. And our last example. Okay, we're gonna hopefully get the hang of this when we see these distributive operations. You guys understand we have to do those first. 9 times x gives me 9x. 9 times 1 gives me 9. I'm just moving the minus 1 down. I'm not doing anything with that 4x because this is where the distribution starts. 5 times 1 gives me 5. And 5 times x gives me 5x. And again, what we notice that each side now has to be simplified before we can start eliminating things. Constant, constant. Let's do just the one side first. So we're going to get 9x. 9 might go on. 9 minus 1 gives me 8. So let's move to this other side. We have variables that need to be combined. So 4x plus 5x gives me 9x. Now, different from what we saw up here. Up here we had exactly the same. Here it's not exactly the same. Okay, the 9x's are the same. And what we know by that is when I subtract 9x to both sides, those variables are going to be eliminated. And I'm going to be left with 8 equals 5. And hopefully you remember when you see something like that, that 8 does not equal 5. So that means that answer would be no solution. Okay. So the difference between these two is this one, any number makes that true. So it's all real numbers. This one, there is no value that'll make that a true statement. So again, 2.3, a lot of what we did in 2.2, maybe just expanded, and also not so pretty answers sometimes, but we're okay with that. And then the introduction of the possibility that we can get an answer of a value for the variable, or we can get all real numbers or no solution. So just really, what's really important about 2.2 and 2.3 is being able to solve these algebra equations. They aren't going away. You will see them a lot more in this course, and you also see them a lot more in your mathematics going forward, whether it's geometry, algebra, a lot of those different mathematics that you will continue to take in college. All right, 2.3.